Swayam Prabha. Digital India. Educated India.
Hello and welcome to our session 32 on quality control and improvement with MINITAB. I am Professor Indrajit Mukherjee from Shailesh J. Mehta School of Management, IIT Bombay. So we are discussing in the last session about measurement system analysis, and within that we have just stratified into two parts. One is for accuracy and one is for precision. So we are discussing about accuracy, and within accuracy what we have discussed is basically bias definition and linearity and stability. That is the mu part that we are talking over here. So this is the mu parts which gets affected. So mean of the observations are if there is an instrumental bias, it will deviate the actual observations somewhat, and the mean will change, the overall observation mean will change. So in this case we do not want any basically biasness in the instrument, there should not be any bias in the instrument like that. So measurement of this bias can be in different way. What we do is that one is known as basic bias, that is what is the average observation and how far it is from the reference point like that. Okay, when I have only one reference information like that, one part, one instrument and one reference, that I am measuring several times and we get the bias information like that. Okay. But sometimes what we are interested into the what we intend to do is that throughout the observation, throughout the measurement range observation, how much is the bias at each and every location like that, because the instrument may be measuring different parts based on the process variability, because the parts will be generated at different range like that. So we do not expect that every parts will be in a specific zone like that. So instrument should be flexible to measure throughout the tolerance zone of the parts like that. Okay. So what is expected is that throughout the operating range the instrument should be able to measure accurately. So bias, let us say vernier caliper, so bias at the observation close to 0 should have minimum bias also, and the observation at a high range of measurement also should be having minimum bias or near to 0 like that. So throughout the operating range of the instrument, the bias should be minimal like that. So that is known as linearity when we are talking about bias throughout the operating range of the instrument, and that is what we consider as process variability, total process variability, and that should be having bias should be negligible like that. So we then only the instrument is suitable like that. And stability study, what we have mentioned is that stability is with respect to time. So the instrument is same and the sample is also same, but sample reading of the samples that we are getting at different time points in morning and evening, let us say, or at different time points throughout for a specific time period, longitudinal study when we are doing like that. So in that case what is expected is that every time it should measure the same biasness should be same. So there should not be any shift in the measurements that we are observing. So so that is measured by stability using control chart techniques, that we are not discussing about stability. So bias and linearity study, we have in MINITAB and options to see the bias and linearity. So in that case what we have done is that we have taken a specific example and we are doing that, and we will continue from there. So the examples that we have taken is that one simple example that we have taken, one part measurement is given and master specimen of that is the master's value of the master samples that is collected over here throughout the operating range. So it can be from metallurgy labs or tool rooms like that. We have a masterpiece that we are measuring with this instrument like that. So in this case, so how many parts are there in C1 column like that? So we can just see this one. So number of observations is part bias over here. So there are 5 parts over here, and 5 will have different specimen values like that. So so the parts that we have taken over here, so in this case we have parts which has a specification of 2 over here. So the first part is having a value of 2, basically the master value is 2 around, and this is the operator who has measured that one. So actual value is 2, or reference value is 2 and this is the observed value like that. Observed value keeps on changing because even if I do not tell the operator what is the measurement of the parts that I have given him. So, in that case he will measure the parts and he will tell me what is the true values of that, what he can measure using the instrument. So, we have to select the operator also very skilled operator over here. We cannot take the measurements, let us say you are an engineer and you are trying to measure that one, that is not feasible. That way we do not do gauge and any measurement system analysis. It has to be done by skilled operator who knows the instrument, who can handle the instrument like that. Those people will do the measurement system analysis. Okay, we will only record and we will only analyze and try to figure out whether the instrument needs calibration, needs to go to metrology lab for further rectification like that or not. That only we can just say about the instrument. Okay. So, and they will take care of the instrument what is going wrong. We have to identify what is going wrong in the instrument, then they will take care of that and they will send us either the old one after repairing, or what you have to do is that they will change the instrument altogether. They will say that this is not possible to rectify, in that case you can use a new instrument like that. So, and due to wear and tear, some at a given time point we have to change the instrument also in production floor. Okay. So, that is natural. So, in this case, so here we have 5 different parts and 5 different parts at different measurements. So, it varies from 2 to 10 and these are the observations that we are having over here. These are the observations that we are having. So, simultaneously I want to see what is the bias at each of the operating zone, that is what is the bias as reference value of 2, reference value of 4, reference value of 6 like this, and we want to see that overall biasness, whether it is overall bias in the instrument, whether it is throughout the operating range, whether it is okay or not. So, for that what we have done is that statistics, we have gone to quality tools and in that case gauge studies, and gauge studies linearity and bias over here. So, then we have given the part bias over here, master over here and response over here, and here there is an option of process variability over here. So, that I am not giving at present. So, and then how do I method of estimating standard deviation over here. So, this will be used for a t statistics, that will be used for p value calculation. So, what I am doing is okay over here. So, what you observe over here is the results that you are observing over here. So, in this case what happens, this we have discussed earlier also. So, in this case what you see is that these are the part observation at reference value of 2, these are the 5 observations that we have taken, and the red points that you are seeing over here is the average value over here. So, average bias is given over here. So, out of these 4 measurement, what is the average observation and what is the reference value, that will give you the bias over here. So, bias is in y axis and reference value is in x axis. So, we can regress bias with reference value over here, and the regression equation is fitted over here with the constant value of the intercept that is given over here. Slope is given over here as minus 0.13167, and slope is coming out to be significant. Test statistics is used over here, hypothesis testing is done for the regression, and in this case what is observed is the slope is significant. So, we do not want slope to be significant in a linearity studies like that. If that is so, that means there is something going wrong at different operating range, bias are drastically changing like that. So, this slope should be insignificant, then only the instrument is okay in linearity aspects like that. So, but the R square fit that you are seeing over here, R square value is about 0.71 like that, and then we have a values over here, what is the reference value and correspondingly what is the bias, whether at 2 reference value whether it is significant or not. So, it is significant at 2. And 4 and 6 it is not significant, but 8 and 10 it is significant. So, it is measuring at the lower range and higher range, which is significantly bias is significantly having a statistical importance over here. That means statistically significant basically. So, at the reference value of 2 and 8 and so lower range it is having a high bias or significant bias, and the higher range also it is measuring, but in the middle range what we are observing, there is no as such bias is not so significant over here. So, although overall the slope is linearity is significant over here, that is because of at the lower range bias is high and the higher range also bias is high. At the lower range what we are seeing a positive bias is reference over here, and the lower range and the higher range of observation what we are getting is that negative bias is observed over here. So, this is the basic interpretation. So, whenever there is a bias, when bias is changing in the operating range, we need to correct that one, and slope should not be significant. That is the overall interpretation that we can make out of this Okay. Now, sometimes what happens is that they calculate a linearity index also, they calculate a linearity index also over here. So, what you have to do is that quality tools over here, you go to case studies over here and you go to linearity over here. Only thing is that process variability you have to mention over here, based on which these linearity values will be calculated, and based on that whether to accept the instrument or not to accept the instrument, that you have to do. Okay. This is mentioned as 6 multiplied by historic standard deviation of the process, like that. So, what we can do is that this is response taken from the process only, that means the range of values is taken from the process. We can say that this is the part variation. So, what we can do is that we can just see what is the variability over here, standard deviation of this. So, we can just take that one. In statistics, what we will do is that we do not want all information over here, we need only the standard deviation information. So, we will eliminate all other options over here, and then we will click OK, and let us try to see that whether this information can be used. It is around 6.7, 6.775, let us say 6.75 over here. So, this is 6.75. So, in this case I can use the calculator. So, 6.75 over here, if you multiply it with you have to multiply with 6 over here. So, this is around 40.5, this is around 40.5. So, what we will do is that here we will go to quality tools and then case studies and linearity and bias. So, in this process variability we will write 40.5, what we have got over here. So, in this case, and in the options what you do is sample standard deviation. So, that is okay. So, I will click OK over here. So, when you do this you will get a different percentage linearity over here. So, MINITAB calculates percentage linearity over here. Okay. So, based on this slope over here, slope value multiplied by process variability, that will give me a linearity percentage over linearity values over here, that is mentioned at 5.33 over here, and we can convert the percentage linearity and again multiplied by again multiplied by process variability. So, one is slope divided by process variability and another is multiplication. So, overall it will be around 13.2. So, the standard that is followed in industry is that mostly if it is less than 30% like that, they can, but it varies from industry to industry. I am not saying very specific like that. Okay. Somebody can say 10% we will allow, linearity 10%, more than that we will not allow. But overall what we see is that even if we do not go by this, we see whether the slope is significant or not, like that. Not sometimes statistical significance does not imply it is very high, highly significant, means practically it may not be so much so much critical like that, but that is why we are using process variability measures over here, and we are finding out the percentage, how much is the linearity or this shift deviation with respect to the process deviation, like that, with respect to the process deviation, like that. So, these measures can be taken based on the industry standards what you are following in your industry. So, so that way we can express linearity over here. Okay. But when we are doing this study, what we are getting is that one linearity percentage MINITAB also reports like that. So, and there can be criteria for different industries. So, somebody can take 10%, somebody can say anything less than 30 is okay, but there needs to be some corrections over here. So, percentage linearity is a concern. Whenever it is more than 30%, it is a concern. Whenever it is more than 30%, that means it is highly significant. So, in that case we have to take some measure, because bias is changing drastically over here in the operating range, but that information where it is changing, we will get this information over here. Okay. So, this is one aspects of when we are talking about mean, and that aspects we are covering over here, and but there can be also impact on variability, that means impact on variability, whether the, now this is bias, we are talking about the bias aspects of that or accuracy part of that, we have to shift to now variance, we have to shift to the variance information, whether the variance of the instrument is quite large or not, that we have to see, and that study what we do is known as repeatability and reproducibility, RNR study. Okay, gauge RNR study also they calls it a gauge RNR study. Here we are more concerned about this sigma measurement over here. So, we are concerned about this sigma over here, and variation due to the measurement system over here can be contributed by two aspects over here. One is known as repeatability of the instrument and one is known as reproducibility of the instrument over here. What is repeatability? If you are measuring it same parts like that, there will be some variation in the measurements like that. So, same operator is measuring repeated times like that, and the instrument will have some variations like that, that will contribute to the repeatability aspects of that, that is known as error aspects of that in the instrument. So, that is repeatability. So, this is basically common variability. everywhere there is these types of variation will happen, because same instrument, if I am doing it second time, sometimes readings may somewhat deviates in that, and that variability that amounts to that amount of variability is represented by this measure which is known as repeatability over here. Okay. And what is reproducibility? Because we are measuring by, because in shop floor what happens is that there are different operators. So, there are different operators over here. So, and in every shift there can be a different operator. So, what is expected is that all the operators should measure the same parts with same accuracy like that. That does not happen. Operator to operator variation can happen. So, operator A measures somewhere over here, operator B is measuring somewhere over here, operator C is measuring somewhere over here. So, overall mean of location over here for operator A is different from the second one and third one like that. So, this variation that is happening due to operator is known as reproducibility. So, this is reproducibility and this is known as repeatability like that. So, a specific kind of study is recommended over here, which is known as gauge RNR study, which is repeatability and reproducibility measure, and that we have to. So, in this case what happens is that in this study what happens is that I have a measuring instrument which is the same instrument that I am doing, and there will be different parts, like in linearity study what we have taken throughout the operating range, we will select the parts like that, and then there will be different operators. So, here we are having a change rather than linearity where single operator was used, here there are multiple operators over here. So, in this case these are 3 operators that is selected over here, and based on that we will do the study, and this study will be done by using we can use 2 types of methods over here. I will discuss only one method which is known as two-way analysis of variance method, which we have already studied like that. Okay. So, this is two-way analysis of variance method that we will explain over here, and the way study is conducted over here that we will explain, and how to analyze the data that we will explain, and what is to be seen that is to be will be elaborated in this session over here. Okay. So, here what you have to do is that they have selected different parts like that in the operating range. So, this is the 10 parts that is selected over here, and these are the observations for a specific part from a specific operators like that. So, this is basically repeatability of the observations that we are happening. So, same sample is measured by the same operator several times over here. This is 3 times that is measured, n equals to 3 over here. So, this is nothing but we can think about repeated measurements what we are taking over here. Okay. So, similarly operator 2 will measure the same parts, part 1 like that, and the third operator will also measure the same parts like that. Now, this total experiment that you are seeing over here is randomized over here, and the operator does not know which part he is measuring, basically which part he is measuring. So, part number will be randomly generated over here, and it will be given to some operator and measurements will be taken like that. So, this is randomization is ensured so that no biasness, there is no bias as far as operator is concerned like that. So, operator does not know next part what is the measurement of that, which part it is coming like that. So, randomly we will generate, and this data will be generated like that. So, 10 multiplied by 30, 30 multiplied by 3 is 90 observations we have. So, it is like design of experiment. So, what is the factor over here? So, one is the parts, that is the one aspects 1 to 10 number of parts over here, and there are 3 different operators. So, operators, operator 1, operator 2, so level 3. So, this is at level 3, and there are 10 parts over here. So, this is part and operator, that is the factor that we have considered over here. So, it will be a two-way analysis of variance that we have already studied like that. So, we will fit this data into MINITAB, and the results we will just try to see over here. So, these parts that we have selected is within the process variability like that. So, this is we can think of that overall process variation is covered over here. So, generally when parts are selected, that will be from the process, and it covers more or less the outcome of the process like that, CTQ outcomes like that. So, we want to ensure that part variation will be there, because intentionally we have selected different parts like that, which is having different measurements like that. We cannot select parts which are very similar in observations like that. So, 1 to 10 parts are at different range like that, and there is some difference between the observations. So, they are basically unique observations that we are having over here. So, so this covers the overall variation tolerance zone of the CTQ, basically what we are covering over here. So, this is taken from the process, these 10 parts will be selected like that. This data will be feed into MINITAB, and then we have to see what is to be done. Okay. So, when this is the data set and it is taken from Montgomery's book Introduction to Statistical Quality Control. Is another very good books that you can, and the way that we are doing over here is basically following a guideline, that is Measurement System Analysis Reference Manual, which is developed by Chrysler, Ford, General Motors Supplier Quality Requirement Task Force over here. So, this is AIG standards that we are following, and there are manuals, you can see manuals of AIG for measurement system analysis, and we are going by the manual, and we will somewhat deviate if required, otherwise more or less what manual says we are going by that, and MINITAB also does what is given in the manual basically. Okay. So, and also you can see QS 9000, that is earlier when people used quality systems in automobile industries like that is the certification like ISO 9000 certification. There is a QS certification which is changed recently. So, anyway, so that there you can get the standards of measurement system analysis. So, two-way analysis you already understand. So, we are doing this experiment setup. I have told parts are different, operators are different, and we are taking repeated observations. So, why we are doing repeated observations? Because we will go by the average value, we will be more accurate, more number of. So, we have taken n equals to 3 over here. If we have increased this one, more accuracy we can assure out of this study. So, this is basically design of experiments what we are doing, and this is two factor experimentation that we are doing over here. So, this measurements is there in my MINITAB file, and that is given at the last part of this. So, this part Montgomery, operator Montgomery, and measurement Montgomery, because this is a Montgomery's example. So, I have taken from there. So, what I am doing is that these are the three observations, 90 observations is given over here. So, all these 90 observations we are just going to analyze using gauge RNR study like that. Whenever you have fed the data, what happens is that then you have to go to quality tools, and then you have to go to gauge studies, and then you have to take gauge RNR study crossed. You have to see this one, that we are selecting this one, cross studies over here. So, in this case what will happen is that it will ask for this where is the parts measurement, where is the operator measurements like that. So, you have to mention which column is what. So, part is given in this one, operator is given in basically operator is given in this second one. So, this is not the correct one. So, we have selected this is part over here, this is, and the measurement that we have taken at the end, this is the measurement of Montgomery that we have taken over here. ANOVA analysis we have clicked, not this one, we are analyzing this one. So, in this gauge information you have to provide all details over here, and in options what you have to do is that the standard deviation, study variation is taken as 6 over here. So, then what you can do is that you can later on we will come back to this historic standard deviation. So, that needs to be calculated and put over here, so that we can also calculate study variability like that. So, we will not do it as at this time point. So, in this case what we will do is that we will click OK over here. Whenever we have clicked OK, what will happen is that you will get so we will make an Excel, we will open an Excel sheet over here, so that we understand and see it clearly what are the results. So, two-way analysis of variance is prepared over here with interactions that MINITAB automatically does it for you, and it indicates some important things over here. So, what we will do is that we will just click this one, and we will copy paste the information that is given over here. So, I am copying this as a picture, and I will paste it in Excel sheet, so that it is visible for everyone. So, what you see is that source of variation. So, part to part variation. So, part is one of the factor. So, in this case that is significant, and it is expected that part variability is will be part to parts are different. So, this will be significant. We are not bothered about this one. We are bothered about the second part, which is operator to operator variation, that whether this factor is significant or not. That means, when operator A is measuring, is he measuring differently as compared to operator B and C like that. Now, what you observe over here in the ANOVA analysis, what it signifies is that operator is basically significantly different, because the p value is less than 0.05 over here. So, operator to operator measurements are differing over here. Then, is there any interaction between part and operator over here? That is also significant over here. That means, operator A measures part A differently, but that same operator measures part 2 differently. That means, the method there is some interaction over here. So, depending on the part, measurements also comes depending on the part. So, operator measures part based on there is a dependency between parts and operator. So, there is an interaction between part and operator, that is also not required. Whenever it is less than 0.05, we are concerned about that. but if it is more than 0.05, that is a favorable situation. Similarly, operator p value is more than 0.05 is a favorable situation. So, we want part variation to be significant, but these two operator variation and interaction effect to be not significant like that. So, that is expected, but that is not so over here. So, let us see the next part of that. So, next what we have is this variance component and percentage contribution over here. So, this calculation we have to explain by using a diagram over here. So, this is the PPT we have gone. So, this is the observation that you see the first part over here. So, this is the first part that you see p value of parts is significant, and that is expected, but these two are significant, that means we are concerned about this, but this is statistical significance over here. So, and these values what you see repeatability or error, we can think of error over here, that measure is basically repeatability, that means that is the measure of repeatability, and mean square of this is considered as repeatability over here. So, when I say source of variation that MINITAB provides in the variance component, that you will see the next result what it shows. So, in this case repeatability is nothing but this mean square is represented over here. So, this is same as this one, what you see over here is same as this one over here, repeatability. Similarly, we can calculate that what is the operator contribution of this source of variation over here. So, this is the operator contribution of this. So, in this case the formula is given. So, you have to take mean square of operator which is given as this one, and then we have to calculate mean square of interaction between operators and parts like that. So, this is the operator part interaction. So, you subtract this from this and divide it by a multiplied by n. So, what is a? A is the number of parts and number of replicates over here. Number of parts is 10 over here, and the number of replicates is basically 3 over here that we are taking. So, if you do that one, what you will get is that you will get operator variation over here, which is the variance component over here. Similarly, there are formulas to calculate reproducibility and interaction part of this, and part to part variations also you can calculate, and overall total variation is given as 50.0963. So, and this total gauge and RNR values that you are getting 1.8037 is nothing but summation of these two, repeatability and reproducibility, that comes as a total gauge RNR variance component over here, which is 1.8 like this. Now, summation of this and this part variability. So, part variability is expected to be very high. So, this is expected because parts are different. So, most of the variation contributed. So, in this study most of the variation is contributed due to change in parts. So, this is expected over here, and then percentage of that we can also calculate. So, if I convert this 48 out of 50, this is around 96. Similarly, we can calculate the percentage contribution over here, and the overall contribution will be 100% over here. So, the overall is 50. So, with respect to 50 what is coming, we are just mentioning over here. So, whenever we have mentioned this percentage contribution is an important measure to accept or reject the instrument like that. So, generally what is taken is that less than 9 to 10% we can think of. So, standard says 9 to 10%. So, I have just written 10% over here. It depends from industry to industry, it will differ like that. So, generally it is taken as percentage contribution. Whenever it is less than 10%, we will go by that measures as the acceptability of the instrument as when the variance component is concerned over here. So, total gauge RNR study, this variance component should be less than 10% that we are recommending over here. So, if it is less than 10%, then we are okay with the instrument like that. But what is our concern over here? Although it is less than 10%, there is some interaction between the parts and operators, and operator to operator differentiation is happening over here. We need to see what is going wrong over here. So, if we can minimize that variability will also reduce, although the significant we are not getting high values over here because this is 3.6. So, you have to be judgmental over here. You cannot be statistically significant. So, we will reject that one. No, we have another criteria of acceptance. There are various criteria in measurement system analysis which needs to be considered before we take a decision whether to use the instrument or not to use the instrument like that. Okay. This is one of the measure, percentage contribution like this. We can also find out the with respect to process variation, there is another measure which is which percentage variability. So, we can also go to that PPTs over here. So, this is calculator over here. There is another important component over here that you see standard deviation, study variations over here. So, if I copy this, we will copy as picture over here and we can paste it over here. So, we can paste this information over here and we can just enlarge this image over here. So, what you observe is that this standard deviation 1.34 is nothing but what you are seeing. So, this is the variance repeatability that you are observing. So, it is sigma square. If you take a square root of this, you will get So, if I can see this one, so if you see this one, so this is the variance component that we have calculated, this is the variance component 1.8037. So, and then standard deviation we can also calculate. So, if you take the square root of this, it will be 1.34. Similarly, all these values are calculated. So, this is basically represented, this is variance component what we have collected, total gauge R&R. So, standard deviation is just square root of this, and if you take the square root of this, and then you get all the components over here. Similarly, if you want to see the study variability, you multiply it with 6, and 6 multiplied by standard deviation gives you all this measure over here, and based on this we can calculate also study variation, percentage study variation. So, 8.051, this is the study variation with respect to total, how much it is? It is around 18% over here. Okay. In addition to this, what we can do is that we can also add process variability, historic process variability over here, that is also possible to be incorporated over here, and that gives you a different percentage over here, which is 22. How this is coming? So, that we can see. So, this is how the calculation happens in MINITAB interface is that. So, after this what you can do is that you can just mention, so study variations of this. So, something we have over here, let us try to see whether we have given this one, gauge R&R crossed over here. So, this is options over here. So, in this case 6 standard deviation with respect to percentage standard deviation, and this is calculated from the historic information, or this is calculated from the sample. So, here what we can do is that we can provide information over here. So, percentage study variation. So, this is done over here. So, one second. So, this is the slide, let me go back to the slide. So, process variation, we have given information of the process variability over here, that is why this percentage is calculated, percentage process variation is calculated over here. So, let me go back what we can give over here as process variability. So, what is required is that I will go to MINITAB, and then let me try to see what is the variation of this process. That is the last one. So, we can calculate the basic statistics, display basic statistics. I want to see the Montgomery's measurement, and I want to see the standard deviation. We only want standard deviation information over here, and this is around standard deviation is 6.75, no. So, 6.75. So, we can just calculate 6.75 multiplied by 6 is around 40.5, that we have done now. So, 40.5. So, what we have to do is that stat quality tools and gauge R&R studies. So, gauge crossed over here. So, in this case options what we provide is that 6.75, we can write 6.75 what we are getting over here, and we can also say that use parts to estimate the process variability over here. So, I will click observations historic, we can replace that one with the measuramental variations what we have, but we can also say use parts in the study to estimate process variability, that is the overall process variability, we can indicate that one. When you click this one, and it will go by the that measure only. So, when I have clicked this one, so it will estimate process variability or standard deviation based on the observation that is given in this experimentation that we have considered. So, if you click OK, then you will get this information, which is percentage process variability over here. So, if I copy this one and we can paste this over here, and then we will have another information over here, that is 19 point what we observe over here. So, percentage process variability. So, study variation is measured over here in respect to. So, more or less study variation, if it covers the overall process, it will be more or less near to this one, study variation and percentage process variation over here. So, the criteria that is used for the study variation process variation is that whenever it is less than 30%, we try to accept that instrument. So, if it is less than 10%, very good instrument, 10 to 30%, what is recommended is that you need to be very precautious and see whether we can reduce that one variability that is happening. Process variation, with respect to process variation, study variation, if study variation is contributing more with respect to process variation, then that is a concern for us. Operator to this part to part variability will be high, and this summation of this, what will happen is that it will not turn up to be 100 over here. So, this is 100 over here, but this is with respect to ratio that we are taking over here, and study variation and process variation, and then percentage we are converting. So, it will not be equals to 100 when we sum this up. So, the criteria over here is that when we go by that contribution, it should be less than 10%. When I going by study variability or process variations over here, then the criteria may be 30, and it depends on the industry to industry what is the standard. But overall concern over here is that we have operator to operator variations is happening, and also part to operator there is a interactions that is observed. So, we can correct that one and try to see more into the instrument and figure out what is going wrong, but the instrument can be suggested for use for the time being. and we figure out how to reduce this one interaction between parts and operators, and operator to operator how we can reduce that one further, so that it becomes insignificant basically. So, we will stop here. What we will do is that we will continue with some more examples on this which is taken from the manual, QS manuals like that, okay, and some more examples where we have bad instruments like that. So, how to understand that one, and graphical display that we are having. So, we want to explain that one also, because when you get the MINITAB information, we also get a graphical interpretation also over here. So, what is this graph, meaning of this graph, that we will explain after this, before we enter into design of experiments basically. So, thank you for listening.